The question reads, a tap P can fill a tank in 2 hours. Tap Q can fill the same tank in 4 hours. Tap R can empty the tank in 3 hours. A, if tap R is closed, comma, how long will it take tap P and Q to fill the tank, Now, let me solve this one first. The tap P can fill a tank in 2 hours. So the work done, if we let the water to be filled, to be 1 unit. The water to be filled is 1 unit. And then we also say that we also let time P and Q can take B T hours. And then if we take the time P and Q can take to be T hours, and the work to be done to be T, and therefore we ask ourselves, if P fills in 2 hours, it fills the whole 1 unit in 2 hours. So 1 hour it fills 1.5. It fills a half. So that means 1 hour P fills 1/2, because it takes 2 hours the whole unit, so it is 1/2. It is 1/2 units. So the part of work done, the part that will be filled by P for T hours will be equal to half T. We also do the same, that is for Q. So 1 hour, what Q does in 1 hour, Q fills. So you realize that Q can fill the same tank in 4 hours. So 1 hour it fills 1/4 units. So the work, that is the part filled, the part that will be filled by Q for T hours. For T it will be equal to 1/4 T. So the part that will be filled by Q and the part that will be filled by P both add up to 1. So it implies that 1/2 T plus 1/4 T equals to 1. So what is T? 1/2 T plus 1/4. If we add the two, 1/2 T plus 1/4 T is 3/4 T. So this gives you 3/4 T, which is equal to 1. So times the reciprocal, which is 4/3, times 4/3. So this will cancel out. T equals to 4/3 hours. And this is the same as 4/3 hours is the same as 1 1/3. This is 1 1/3 hours. Remember, a third of which is equal to 1 hour. A a third of 60 is 20 and 20 minutes. 1 hour, 20 minutes. So that is the time P and Q can take to fill the tank. P and Q can take 1 hour, 20 minutes to fill the tank. Now part B is saying that, part B of the question is that we calculate how long it would take, to fill the tank when the three taps P, Q, R are running. So how long will it take? So we do the same thing that we have done. That is the whole unit. So that means P and Q, P plus Q in 1 hour, will be equal to, like we said, is a half and a quarter. So it is a half plus a quarter, which is equal to half plus a quarter gives you a 3/4. It gives you 3/4. So it gives 3/4 units. Now we had let the time to be taken. If we let the time taken, let the time taken by the 3 to be equal to t. So if the time taken by the 3 to fill the tank to be equal to t, and remember our R is M time. R in 1 hour. In 1 hour, it's emptying the tank. It takes 3 hours, so it empties the tank it empties a third unit. So that means the work done, that is part filled by P and Q alone is 3/4 of the whole time in T, and then and the part emptied by R is a third of the whole time T, and that means the two of them will add up to 1. That is 3/4 T minus a third T. This equals to 1. This equals to 1 because this was empty and this the what was filled, the part that was filled by the 2 in T hours, and this the part that was emptied by R in T hours. And therefore, if we do the same, 3/4 minus, that is 3/4. If you get 3/4 minus a third gives you 5/12. This gives you 5/12. T equals to 1. So we multiply by the reciprocal 12/5 times 12/5. So this cancels. T equals 2. 12/5. This is the same as 2. That is 2. That is 5. 5 will go to 10 2 times, remain with 2. So it is 2 and 2/5 hours. 2 and 2/5 hours. Or you can say 2 hours 24 minutes. Or 2 hours 24 minutes. 4 minutes. So those are some of the questions you can expect in this topic. Those are some of the questions you can expect in this topic. I'd like to do one more question. I would like to do one more question so that I leave at that point. I want to do this question. Example 3 of these type 2 questions is that Mogaka and Onduso working together can do a piece of work in 6 days. In 6 days, Mugaka working alone. Mugaka working alone takes 5 days longer than Onduso. How many days? How many days does it take? Does it take Onduso to do the work alone? Now, in this question, Mugaka and Onduso working together can do a piece of work in 6 days. So we are given T. The T that we are looking for, that is for the two of them we are given. Mugaka working alone takes 5 days longer than Onduso. So we need to let Onduso take X days to finish the work. And that means Mugaka takes X, because we are told that Mugaka working alone takes 5 days longer. So Mugaka takes X plus 5 days. How many days does it take Onduso to do the work alone? So we do the same way we were doing from above. So the T now we have it, which is 6. Now we need to find that the 1 day, in this case now we're talking about days and not hours. So you use what you are given. So in 1 day, so you say 1 day Onduso, the work Onduso does in 1 day, Onduso does 1 over X of the unit, because the whole unit is 1. So he does 1 over X units in 1 day. Then the part done by Onduso, part of work done by Onduso, but in 6 days. That's Mugaka and Onduso working together. They do 6 days. So the part of work done by Onduso equals to 1 over X times 6, which is equal to 6 over X. You do the same to get the part of work done by Mugaka. So part of work done by Mugaka, the part of work done by Mugaka equals to, in 1 day he does 1 over X plus 5, then times 6 days, which is equal to 6 over X plus 5. So this implies that the part done by Mugaka and the part done by Onduso add up to 1, because the whole work was 1 unit. So that means it implies that 6 over X plus 6 over X plus 5 equals to 1. So if we find the LCM here is X into X plus 5, then we do here, X comes here, X plus 5, so 6 into X plus 5, plus, this comes here, X, which is 6X, gives you 1. I continue here, so that we have now, we open this bracket, it gives 6x, that's 6 times x, 6x plus this gives you 30, plus 30, then plus 6x, all over, you open the bracket of the numerator, becomes x squared plus 5x, x squared plus 5x, this is equal to 1. It's the same as 1 over 1, you cross multiply. If you cross multiply, it becomes x squared plus 5x equals to, cross multiply there. First of all, this is 12x. 12x, so it will be times 1, this is 12x plus 30 times 1 becomes 12x plus 30. So we make this a quadratic equation. So it becomes x squared plus 5x minus 12x minus 30 equals to 0. So this one gives you x squared, this is negative 7x minus 30 equals to 0. So from here, I can use the complete, I can use the formula method. I say x equals to, remember formula method states that x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. So if I employ the same here, it means x equals to, our b is here, so it is minus b, which is minus 7, it is 7 positive, plus or minus the square root of b squared, 7 squared is 49. Because of this negative, then 4ac will be equal to positive. So it is plus 4 times 30, which is 120, all over 2a. A is 1 all over 2. So our x equals to 7 plus or minus, this is 169. The square root of 169 is 13 all over 2. Remember, we are looking for days, and the days 7 minus negative. So we pick the positive. So our x will be equal to 7 plus 13 over 2, which is equal to 20 over 2, which is equal to 10 days. So the time was 10. It was 10 days. That is, the time Onduso could take to do the work alone was 10 days. X days, that is Onduso. So the time Onduso could take to do the work alone is 10 days. So that is how you do such questions. If you follow well, this is the shortest method of doing it. Thank you for listening, and ensure you subscribe before you leave. Thank you. Welcome to today's tutorials, and I'm going to take you a Form 3 topic, and that is compound proportions, rates of work, and mixtures. But specifically for today, I'm going to tackle rates of work. Rates of work, I start with, I'll discuss 2 types of questions that you expect in this subtopic. That's that when questions, like this example 1, is a type 1 question, that 195 men working 10 hours a day can finish a job in 20 days. How many men employed to finish the job in 15 days if they work 13 hours a day? Such kind of questions are tackled in several ways by different people, but you realize there is a method that people use whereby if you apply it, the method does not give answers to all questions. So I'm going to show you a method that works for all. For instance, in this case, if you interpret, you write, for instance, that is solution here. We write, for instance, we talk about men. Let's talk about, we write men. And then we also talk about the hours they take. The hours they take. And then we talk about the days they take. Now we talk about 195 men here. They are 195. The men are 195. They are working 10 hours a day. Can finish a job in 20 days. Then you're asked that how many men employed to finish the job in 15 days. Employed to finish the job in 15 days. So they finish 15 days. If they work 13 hours a day, how many of them? Let's call them X. Now, for this question, you will be lucky if you use that method where people employ that all these, some people say that 195 times 10 times 20 equals to X times 13 times 15, whereby now X equals to, that is if I divide by 13 times 15, I divide by 13 times 15, that means this cancels, so that you remain with X equals to 195 times 20 all over 13 times 15. You get 200 men. This one you are lucky, it works. But this method does not work for all questions. This does not work for all questions, and therefore I usually tell my students that they should not use this method because it does not work for questions. Like for these questions, if you employ this method, it will not work. For this question, if you employ this method, it will not work. And therefore, that is why I've written two questions, two examples, this one and this one. This one works for both methods, but this method cannot work for this question. And therefore, I tell my student to not to use that method. So the method to use is a very simple, it's a method of reasoning. It's a method of reasoning whereby you just ask yourself, my reference point is the man, because that is what I want. I want the man, so it's my reference point. Assume this was not there. If this is not there, you are just comparing the hours and the men. You start comparing the hours and the men. You ask yourself, if 195 people are doing in 10 hours, 10 hours is 195 people. 13 hours, will we need more people or less? 10, we need 195. So you ask yourself, 10 hours is 195 people who are doing the work. So if we increase the time to 13 hours, so that means we have less people. We have less people. So the ratio is less all over big. So it will be 10 all over 13 times. Our interest is here. So that is how we need to find x. That is, we say that our x equals to 10 all over 13 times. Then now you assume this one also is not there. You ignore the mid-row one. So you ignore the mid-row one. Now you ignore this one. You consider this and this. Now you argue the same way. If people, 20 days, the work being finished in 20 days, it's 195 people who are finishing the work in 20 days. 195 people are finishing the work in 20 days. So if the days are reduced, to 15, how many people are required? Obvious, if you reduce the days, it's automatic that you have increased the number of men. You have increased the number of men. Regardless of the hour they work, just ignore the hour. So that means you have to increase the men. So it means it's more or less. So in this case, our more is 20 and our less is 15. So times 15, times more or less, which is 20 over 15, that is the ratio. Then times the 195 that we were given. Times the 195 that we were given. So that is how this is the best way of reasoning out of doing this rate of work. And therefore x is the number of men, x equals to, that is 10 times 20 times 195 all over 13 times 15, this gives you 200 men. That is the simplest way of doing it, and that's the better way than the other method. Because if you employ the other method in this question now, example 2, that if 20 men, so we are talking about the men here, we are talking about the men, can lay 36 meters, so the meters here, that they can lay of a pipe in 8 hours, then we have hours. So here we have 20 men, can lay 36 meters in 8 hours. Then you are asking that how long will 25 men take to lay? It is 25 men. How long will they take to lay the next 54 meters? The next 54 meters of pipe. How long will it take? So remember this one. If let's say we call it x, they take x hours. If we do like we did the other one, maybe if you try it, that is 20 times 36 times 8 equals to 25 times 54 times x. If you divide by 25 times 54, divide by 25 times 54, this cancels, so that means x. If you calculate this one, gives you 4.2. 4.2 hours. And this is wrong. This is wrong. That is wrong answer. So that means if you calculate this one, gives you 4.2 hours, which is a wrong answer. A wrong answer. Therefore, that method does not work for all questions. So that's why I said that we use the reasoning method, whereby now our x becomes x equals 2, we start the reasoning. If you close this one, assume this one is not existing, now you work with between this, you ask yourself, 20 people are doing the work in 8 hours. 20 people are doing the work in 8 hours. 25 people, will they do in more or less hours? obvious if you have increased the number of people, so that means they do in less hours. They do in less hours. So it is 20 all over 25 times. Then you ignore this one is not now existing. The men are not existing. You just deal with the meters and the hours. That is 36 meters is done in 8 hours, regardless of who are doing it. So that 6 meters is done in 8 hours. If 36 meters are done in 8 hours, 54 meters, will it be done in less or more hours? Will it be done in less or more hours? Obvious that 54 meters will be done in more hours, so it is more or over less in ratio form, 54 by 36. So times 54 all over 36, then times now what we have here, 8. So that means our x equals to 20 times 54 all over 20. And that means that x equals to 20 times 54 times 8, 20 times 54 times 8, divided by 25 times 36, divided by 25 times 36, which is equal to 896 all over 900, all over 900, all over 900. And therefore this gives you, which is equal to, that is our x equals to 9.6. 9.6 hours, or in fraction form you can say it's 9 and 3 over 5 hours. 9 and 3 over 5 hours. So that is how the best way of doing these questions. Now I want to go and do type 2 questions. Type 2 questions. Type 2 questions on rate of work. The type 2 questions that you can expect in this topic. The type 2 questions that you can expect in this question. Now let's talk about the type 2 questions. Type 2 questions. Type 2 questions. Example 1. Example 1. The type 2 questions that you can expect in this, a question like this one. It takes 1.5 hours for John to mow a lawn. Linda can mow the same lawn in 2 hours. In 2 hours. How long will it take? How long will it take John? How long will it take John and Linda working together to mow the lawn? Now, in this scenario, what you do, there are 2 ways of doing it, also many other ways of doing it. But I will take you the easiest way of doing this question. That it takes 1.5 hours. 1.5 hours is the same as 3 over 2. It's the same as 3 over 2. Just write in fraction form. It's the same as 3 over 2. So if we take that as same as 3 over 2 hours, this is the same as 3 over 2 hours. So you interpret that way. For John to mow a lawn, Linda can mow the same lawn in 1 hour. So let us say, let us assume that we let the work being done. Is not assuming. We let the mow, that is the lawn to be mowed to be 1 unit. We let the work done. If we let the work done be 1 unit, and then we also let time taken by the two to do the work, by the two to do the work B or BT. We let it to be T hours. So we have let the two to be That is, we have T hours and 1 unit. So it means what? It means that John takes to do the whole unit. That is 1 unit. That is for John. John works 1 unit, does 1 unit in 3/2 hours. So the question is, in 1 hour, John does what? What does the kind of units that John will do? So John will do 1 divided by this. 1 divided by 2, divided by 3/2 is the kind times 1, that is, times 1 unit. That's the work John will do in 1 hour. So John will do in 1 hour 3 out of 2 units. So you realize that, like we have said, John in 1 hour. So John 1 hour will do 3 out of 2 units. So if John does in 1 hour 3 out of 2 units, and the two of them working together for all the time taken, they take 3 hours. So the work done by John in the duration, work done by John, so the work done by John will be 3/2. This is 1 hour times the whole time now, which is 3/2t. So that is the work done by John. So we do the same to get for Linda. So Linda, you realize that Linda here, 1 hour. So if we do the same, you realize that Linda, 1 hour will be what? Linda does it in 2 hours for 1 unit. He does the 1 unit in 2 hours. So means in 1 hour he does 1/2. 1 hour he does 1/2 units. And therefore the work done by Linda, so work done by Linda will be work done for the whole thing, done for the whole unit, the work done by Linda will be 1/2 T. You will do 1/2 T units. And therefore, it means that if Linda does 1/2 T, and this one does 3/2 T of the whole unit, so that means the 2, if you add the 2, it gives you 1. So it implies that 3/2 T plus 1/2 T, it gives you 1, because the whole work was 1 unit. The whole work was 1 unit. So if you add the 2, that is here we want to divide and get 2/3 not. We want to get 2/3, and therefore this is 2/3. This is 2/3 and 2/3t. Yes, so it is 2/3t. 3t plus 1/2 t. So if you add the 2, you will get 7/6t. This is 7/6, t equals to 1. 7/6, t equals to 1. So that means t times the reciprocal, times 7 times the reciprocal, which is 7/6. Times 6/7, the reciprocal is 6/7, times 6/7, all the sides, this cancels out, and therefore our t equals to 6/7 hours, which is the same as 6/7 hours is the same as 51.5 minutes. Yeah, so that is the way of doing it. I want to do example 2. I want to do another example on type 2 questions. I want to do another example on type 2 questions. On these type 2 questions, I want to do another example.